Welcome back to Outward Home Learning. The subject today is computer science, and compression is what we're going to be looking at in this session. So Mr. Halton's going to explain a bit about compression to get us started, and then following that you'll be answering some tasks and exam questions. Over to Mr. Halton.
You're probably watching this video through a service like Vimeo or YouTube or something like that, and you've clicked a button, you've waited for a couple of seconds, and then the video has started. And that's fantastic. That's all due to this thing called compression. If we didn't have compression of data, then you would click that button and you'd probably have to wait, it could be anything from 15 seconds to a minute or two, depending how good your connection is before the video starts. And that's a big problem. Nobody wants to use video services like that. So compression is kind of a big deal, because compression reduces the file size of any file that you might have. So it might reduce the file size of a picture, or in this case a video. And that has two main benefits. The first thing is that if you're sending the file over the internet, like we're sending video over the internet right now, then it will speed up the amount of time it takes to transfer that file. The second thing it does is that if the file is smaller, then it uses less space on your secondary storage device, like a hard disk. And there are two main types of compression that you need to be aware of. The first one is called lossless compression, okay? And the thing about lossless compression is that after I compress the file, I can restore that file afterwards to exactly the same state as it was beforehand. So I'm going to walk through an example of this, and we're going to use this picture here. Now, if you've watched my video on images, and if you haven't, I suggest you quickly go and do that, then you'll know that images are made up of these things called pixels, and pixels all have one color each. So if we have a look at the first line of this image, then I could represent that. If I'm doing just one character, so we say 1 byte per pixel, then I could represent that as white, 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 because the first 4 pixels are white, and then it's going to be black, and there's going to be 8 black pixels, so there's going to be 8 Bs, and then there's going to be 4 whites again. And if we have a look, that's 16 characters in total. So I've used 16 bytes, if you like, of data to represent that first line. But there's a better way of doing it. So instead of having white, 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 I could just say, I've got 4 whites in a row. And then here, instead of saying black, 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 I could say, then I'd follow that by 8 blacks and then 4 whites again. And then if I have a look at the number of characters I've used here, it's 1, 2, 3, 4, 5, 6. So I've compressed that data right down to 6 bytes. That's called run length encoding. It's a popular type of lossless compression, and it gets the idea across that we can reduce data down without necessarily losing anything. But there's another type of compression that you need to be aware of as well, and it's called lossy compression. And this is quite exciting because it means that I can introduce you to my favorite cat picture on the internet, which is this one here on the left hand side now. So if you have a look at this, don't worry, it's not that it's not loaded properly on your screen, it's supposed to look a little bit corrupted. If I have a look maybe on the right hand side here, we're dealing with about 100% of the original file size. So on the right hand side here, 100%. And on the left hand side, right at the edge, you're probably dealing with about 5% or maybe 1%, so a very low percentage of the size of the original file. And okay, on the left hand side, towards the left, everything looks corrupted. It doesn't look fantastic. It probably doesn't get very recognizable as a cat anymore. But maybe about here, maybe about 66% of the way through, when you've got rid of about a third of the data, there's not that much of a noticeable difference. So if I draw a line down here, roughly, then it still looks like a cat. It still looks like it's still a pretty good image. And so that's the idea of lossy compression. We can delete data from the image, and hopefully the human eye won't be able to pick up on it if it's an image, or if it's a sound, then hopefully the ear doesn't pick up on it too much either. But the trade-off for this is that I can't get my original file back. And even though I might hope that I won't notice the reduction in quality, there will be some sort of reduction in quality somewhere, and if you've got a trained eye, that you can pick up on it quite quickly. So there you go, that's compression. You've got lossless, where you can get your original file back and we don't throw any data in the process, and lossy, which is sort of the opposite, where we can't get original file back and we end up throwing data away in the process. But lossy tends to be better compression as well. And that's compression.
So now Mr. Halton's explained compression and how it works. You're going to complete a sorting exercise. You're looking at the advantages and disadvantages of lossy and lossless compression, and you need to sort out the boxes accordingly on the first task. So you're going to get about 10 minutes to do this. Off you go. Okay, time's up. So it's time to have a look at your answers with Mr. Barnes.
Okay, so here we've got a task about lossy and lossless compression, and we've got 10 statements here, and you need to decide whether they're advantages or disadvantages of lossy or lossless compression. Okay, so let's go through these. So files compressed with this method take up less bandwidth and can be downloaded or streamed quickly. Well, lossy gives a higher rate of compression, therefore the file size is going to be smaller and it will take less time to download them. So that would be an advantage of lossy. There's no reduction in the quality. The compressed file should look or sound like the original. So that is lossless because no data is actually removed from the file. The quality of this compression method is worse than the original, although the quality is normally not noticeable. So that's going to be a disadvantage, and it's going to be lossy because lossy removes some of the data whereas lossless doesn't. There is only a slight reduction in file size. This is because no data is removed. So we mentioned lossless has no data removed. It's only going to slightly reduce the file size, therefore it's a bit of a disadvantage because we're not getting those compression rates we maybe want. And then we've got it is commonly used and lots of software can read this type of compressed files. Well, that's lossy. Most of the lossy compression file types are regularly used and commonly used because obviously they get a big rate of compression. Okay, moving over to the other side then. So we've got large reduction in file size, meaning more files can be stored. Okay, so lossy gives a greater file reduction, and that means we can store more files. So that's an advantage of lossy. The compression method loses data. The file cannot be turned back into the original. Okay, so when you uncompress it, you're never going to get it back. Lossy is where data is removed, so therefore you cannot get it back to the original, and it is a disadvantage. This compression cannot be used on text or software files as these need to keep all their information. So lossy removes data, so it will be removing words or whatever from a text file. Therefore it's a disadvantage and we can't use lossy compression on text files. This compression method can be used on text and software files, so lossy can't use it. Guess what? Lossless can, and therefore it's an advantage. And then last but not least, we've got this compression method when decompressed is exactly the same as the original. And that will be lossless because nothing is removed from the file, therefore you can get it back to the original. And there we have it, our advantages and disadvantages of lossy and lossless compression.
So now you've got a much better understanding of lossy and lossless compression, it's time to answer some exam questions. You're going to get 10 minutes to complete these questions and your time starts now. Right, that's it. Time's up. So, time to review these with Mr. Barnes. Please make sure you mark your answers.
Okay, so let's have a look at a couple of exam questions then and model some answers. So we've got here, files are often compressed before they're sent over the internet. State what is meant by compression. Okay, so you could almost answer this without actually having studied computer science. If you compress something, what are you doing? So we are reducing the size of a file to make it smaller. Okay, so 1 mark, nice and easy, state question. So we've got reduce, if we have a look at the mark scheme, there we go. We've got reduce the size of a file, perfect, 1 mark, bang. Okay, next up then, we've got state one advantage of compressing files before sending them over the internet. So if we're compressing files and they're smaller, all that means is it's going to be faster to send or receive them. Or receive them. Okay, so let's have a look at this answer. 1 mark, so we've got state one advantage, we've stated one, and right there you will see transmits more quickly. It will be faster to send or receive them. Perfect. Okay, right, final question then. Let's move this up. We've got 2 types of compression, a lossy and lossless. State which type of compression is most appropriate for each of the following and explain why. So downloading the source code of a large program. So the source code is text, and if we remember back with compression we've got lossy and lossless. Well, lossy removes data, so it removed part of the source code, it would no longer work. Therefore our compression type here is going to have to be lossless. Okay, now we then need to explain why that this one is appropriate. So like I just mentioned, if you use lossy it would delete code and therefore not work. So I'd say lossless does not remove data. This is important because if data was removed, part of the code would be removed, and it would not work. Okay, so the next one is streaming a large video file. Now you could make the assumption at this point that if the first one was lossless, the next one's going to be lossy, and there's a fair chance of that if you're having a bit of a guess, but never assume that. So streaming a large video file, well, we know that lossy gets greater rates of compression because it removes data, and we can remove pixels and reduce the resolution without making it, the video file unwatchable. Therefore the most appropriate type of compression is going to be lossy. Okay, and now our explanation for this is allows you to compress the file more to make it faster to stream. And you can reduce the quality of a video and it can still be watchable. Okay, right, let's have a little look at this mark scheme then, starting with lossless. So we've got here lossless is for the first one, which is great, so we've already got 1 mark just for identifying the right type of compression. And then we've got 2 more marks to gain here. So it says the code has to be exactly as original or it will not work. So I've said here, lossless does not remove data. This is important because if data removed, it would no longer work. So if lossless, or that should probably say doesn't. That's a typo on my writing error on my part. So we get a mark for that, and it wouldn't work. 3 marks. Okay. And then let's have a look at the last one. Lossless. Sorry, lossy even. So the right type of compression is lossy for 1 mark. And we've got here in the mark scheme it achieves a higher compression or smaller file size, faster to stream, and video can still be viewed at a lower quality. So it allows you to compress the file more. Yep. You can reduce the quality and it'll still be watchable. Perfect. 3 marks. There we go.
And that's everything you need to know about compression. We'll see you next time.